Good afternoon, everyone, and welcome to today's webinar, Readily Available Equipment for Response and Recovery. I want to make everyone aware that we may experience some technical difficulties due to so many people being on the network. In addition, this webinar is recorded. For webinar support, please send an email to caesarcoms@epa.gov. Next slide, please. Your audio is muted. So to ask a question, select Q&A on the right side of the screen and type your question in the box, then select Send. Feel free to type your question in the Q&A box at any point during the webinar. We will also have a Q&A session at the end of the webinar. Closed captioning is available. Select Captions/Subtitles in your video controls. To change the caption language, select Settings, then Captions/Subtitles, and choose a language. Next slide, please. Anyone on today's webinar may receive a certificate of attendance. To do so, you must attend this live webinar for 60 minutes. If you did not request a certificate of attendance upon registration and would like one, send an email to caesarcoms@epa.gov. Just a note, EPA cannot guarantee acceptance of certificates by your organization, nor can certificates be provided for viewing the webinar recording. Next slide, please. EPA is virtually hosting its International Decontamination Research and Development Conference, November 1st through the 5th. The conference website is available. Next slide, please. Thank you for being with us today. And now it's my pleasure to introduce our presenters. Matthew Magnuson, research chemist with EPA's Office of Research and Development's Center for Environmental Solutions and Emergency Response. A major focus of his work is management and treatment of large volumes of chemical, biological, and radiological contaminated water and wastewater. Next slide, please. Michael Kaminski, Senior Nuclear Chemical Engineer in the Strategic Security Sciences Division at Argonne National Laboratory, and adjunct associate professor in nuclear plasma and radiological engineering at the University of Illinois. Over the years, Michael has evaluated and developed technologies for the decontamination of nuclear facilities and urban centers following a radionuclide release. Next slide, please. And now I will turn it over to our first presenter, Matthew Magnuson. Thank you. Matthew?
You may be muted, Matthew. Might need to unmute your line.
Please stand by.
Well, it looks like we have some technical difficulties with Matthew hopping on the line. Let me start off until Matthew can establish a connection again. So my name is Michael Kaminski. I'm the second presenter for this webinar. The subject of the webinar today is selecting readily available equipment for wide area response and recovery for radiological incidents. So this is purely for rad nuke events. And this tool that we've developed started quite a few years ago with a somewhat large effort that we had in contacting subject matter experts from around the world and asking the question of, if we had a wide area release event, either an accident from a nuclear power plant or from medical isotope release, or a malicious act, say from terrorism, how would we recover the urban and rural areas? And we concentrated mostly on the urban areas for this part of the study, but we're hoping to expand into the rural areas. And we were not surprised to find out that a lot of stakeholders, emergency planners from the cities and from the regions and from the federal governments, even from private firms that have as their main arm of their business is to do radioactive and nuclear cleanup, that they were not prepared to answer the questions of how you would do such a cleanup and containment activity in an emergency or in a recovery phase, and what types of equipment that can be used, methods and equipment. And so we gathered a lot of information in that time, and we've started to take that information and put it into a tool, which we're calling the RRLT, the Radiological Recovery Logistics Tool. And so this is an intelligent tool for helping stakeholders decide what types of methods and equipment are needed for radiological incidents. Next slide, please.
Michael, I think we have Matthew back online here.
Fantastic.
All right, can you hear me?
Yes, we can.
Okay, can you see what looks to be slide 8?
We see your title slide, so you may just need to advance to the next one now.
And Matthew,
okay.
For your benefit, I did a brief explanation of the prior history that led to the development of this tool. So I think we're ready to go on to the next slide, please.
Okay, I am trying. It's not showing the slide for me, but maybe it will now.
Would you like me to share the slides?
Let me see if it works now. Can you see it now? It's slide 8. It says questions.
Yep, there. That's coming up.
All right. So sorry for those technical difficulties. It worked in the dry run. So anyway, Mike, thanks for that. Thanks for that introduction of the brief introduction of the history of the tool. And so the tool really is trying to address some questions, which we see here. And well, one of the first questions, not really by the tool, is what really the tool's for, and that's for wide area contamination events. And I will talk about that more later. And then, but the real questions that the tool is trying to address is how can we compress the timeline for response and recovery through the use of readily available equipment, and we'll see more what that equipment is later. It's really more like equipment you can rent locally, or maybe a municipality already has. So then, what types of this municipal or commercial equipment really are there? And maybe more importantly, what sort of data is there to support their use and to predict their efficacy? So on the next slide is a little description of wide area events. So we're talking about radiological incidents that contaminate a very large area. On the right side is the Fukushima incident, which contaminated about 9,000 square miles. On the left side are some plumes calculated on the top for a improvised nuclear device detonated in New York City. Not 9,000 square miles, but quite a few square miles. And on the bottom is another plume for a radiological dispersion device, a dirty bomb, detonated in the Philadelphia area. And you see that the plume travels many miles. Those rings are 2 and 5 miles respectively. So quite a bit of an urban area that is contaminated and which you don't want to just seal off. So another question is, when in the incident timeline is this tool for? And so it's not for the first few minutes or even hours after the incident. We've passed that, and immediate life saving is complete. So essentially, what we'd expect to see is that people and vehicles are moving in and out of the contaminated areas for, response purposes and evacuation and whatnot. And so to go along with the movement of people, we need some urgent mitigation to restore the critical infrastructure, whether that's roadways or water systems or whatever else is necessary to make sure the city doesn't shut down. And then various response and recovery missions are underway, and then the remediation is being planned and maybe actually started to be carrying out. So this early phase refers to like around 72 hours, and then that's mostly local responders, we think, and then after that, other parties, including EPA, would be involved in the next days to years or decades for the cleanup. So the tool supports several support goals, which are involved in the response and recovery. And there are 5 main ones here, and they're summarized here, but they're described in more detail in the next slides. The first is to reduce the received dose to the first responders so that they can continue their operations in the contaminated area as long as possible. And so this will be better explained when Mike does demonstrate the tool. But examples of these are pictured here and include like dump trucks to spread certain materials that will prevent resuspension and reduce inhalation of radionuclides and other such very immediate means that will help out first responders. So the next support goal is containment of water and wastewater, with wastewater being usually the result of what happens when you use water, whether that's being by the first responders to extinguish fires that may be created during the perhaps an explosion after the release, but also during certain types of mitigation and decontamination, probably gross decontamination to reduce levels of radiation. So you generally don't want to freely release that radiation into the environment. So the question is, how do you divert that water for proper treatment and disposal? And you see a few options presented here. And speaking of decontamination, gross and final decontamination that the water is used for, it turns out that a lot of these decontamination methods will be much more effective if you can get them in place early before the contaminants have a chance to really stick to the surfaces and environment involved. So really the question is, what sort of equipment can we use really quickly to help carry out this type of decontamination? And so here's some pictures here, but you'll recognize these as things that might be in your community, or in the case of the fireboat, well, you have to be near water, but nevertheless, there are things that could be used very quickly. So another support goal is waste management, and This is a frequently underappreciated part of a radiological response, but as illustrated in the lower right-hand corner, those are actually the waste bags from just one site in the Fukushima area, you know, that 9,000 square mile area that needed decontaminated. And so it can really pile up. So the question is really how to manage that waste while also managing the normal waste that's generated by the city. Because if you recall back on those plumes, not all the city is shut down, and it will need to continue to function. So an example would be, you know, how to repurpose the garbage trucks that are already available to best serve the dual purpose of the RAD waste management as well as the normal waste management. So the other support goal is the surveying and monitoring. Now this is not referring to the initial radiation equipment that first responders might have, but this is, because that's rather plentiful and well known, this is referring to kind of a longer term monitoring in affected areas to understand the dose to the workers as well as the residents that may be not evacuated or once they return. So pictured there's some you know, off-the-shelf uses for these, ranging from air filters as kind of a passive monitor to various other sorts of more conventional and unconventional devices. So back to the tool, just a little bit about the development and current status of the tool. I believe Mike gave you a bit of an introduction to pretty much the several years long history of the tool and its predecessors. And the initial approach to developing the tool, I think, as Mike went over, was essentially to gather subject matter experts together and talk to them about the support goals and try to pick their brains as to what would be the best equipment to use for this. And then that was turned into an implementation of the tool, which was essentially a group of equipment tables for support goals. So you see one here that lists equipment and gets into advantages and disadvantages, and the rest of the page is cut off. And as you can imagine, these pages got kind of expensive. So this transitioned into the current implementation of the tool, and I'll turn it back over to Mike to talk more about that. So Mike.
Thank you, Matthew. Can you hear me clearly?
I can hear you.
Okay. And now on the screen, you should see a page, a web page showing the radiological recovery logistics tool. Is that correct?
Yes, we see that.
Okay. So when you log into the tool, for which you need credentials to log in, this is not available just openly. You're shown this page, and so the different parts of the page are that the top is the navigation and information bar. Here we have a search engine that allows you to type in any information that you have. Say, for instance, you are coming from a planning meeting and you have methods that you want to employ and want to learn more about. You can type those methods in directly here. If you're coming from a prior developed manual, for instance, the UK Recovery Handbook for Radiological Incidences is a well-known international manual. It has its own terminology for different types of methods that can be used in terms of recovery from a contamination event. Those can be directly used here in the search bar. In this pane here is what we call the subject pane. And so it's really gives you all the information and options that you have that can be inserted into what we're calling the active pane, or the active plan. So the active plan is contained here. We'll keep a running list of all the different types of methods and equipment tools that you add into the active plan, and we'll go through that pretty extensively here. There's a third pane here that's called previous plans. If you had developed a plan prior and you saved those plans would show up here so that they can be recalled and printed or distributed. So for instance, let's start with something simple like the search bar. In the search bar, say you're coming from the UK handbook and you know that you need to take care of contaminated leaves. Okay, so if you just type in here leaves and hit enter, the wizard, which is the artificial intelligence behind this tool, will use these search terms and any of the values that you click into the active plan, and it will start to deduce what direction you're going in order for it to recommend methods and tools to help the user. So it's not a blind tool that's just waiting for user to click yes I want this, yes I want this, yes I want this. It has more intelligence in that, and it does infer based on your responses what you might be looking for to help you make a decision. And we'll go through a little bit of that. We're still developing the artificial intelligence behind this, and so not all the features are going to be shown. But in this case, we type in leaves. The wizard understands the different aliases for leaves. So it could be a leaf, it could be trees, it could be foliage. And so it starts to take a guess at what you're trying to find. And so it'll start to rank these things in the order either in which it feels its inference is more strong at the top and then less strong at the bottom, or if it can't make an inference at that point, it'll just start to list them in alphabetical order, which is what it has done here. And so it's already it understands that leaves, well, that lines up very well with collection of leaves. So it's asking, okay, do you mean collection of leaves, which is a recovery method? So let's go back again here and go through what we mean by recovery methods and then remind you of the support goals. So in this opening screen, the active plan is just going to be showing the 5 support goals. Now the support goals are aligned with the objectives that are taught with the incident command system. And so it's not exactly lined up, so we hesitate to call it an objective because it doesn't have some of the specificity that's usually required in an objective. But the support goal lines up with a broad objective, and then the scenarios start to narrow down that objective and start to become more like a strategy. And then with recovery methods and equipment types, you start to become strategies and tactics. And so there is a correlation between those terms that are used in the incident command system, but it's not direct. And so that's why we hesitate to call these objective strategies and tactics. But for the support goals, again, these are general objectives. We have the 5 support goals that are listed here. In the newer version of the tool, which is not ready for live, we have changed this format, and it now looks more like a timeline from the early side of the response to the later recovery phase. And these are in that particular order. So mitigation of received dose would be something that would be in the earlier part of the response and recovery, and so it's going to be the first support goal. Containment of wastewater may be necessary in the early phases, say after performing firefighting activities where water is generated, and now we can expect that to be contaminated water. And so we may want to deal with that very early on. And then the next 3 support goals would be more appropriately termed as recovery type activities. And so those would be later in the timeline. So in the support goal, if you click on, these are short descriptions of the support goal, but if you go over the info bar, then it'll give a little bit more explanation. And in the newer version of this tool, the nomenclature changes a little bit. The explanations are expanded a bit and refined so to avoid confusion. Because again, we were adapting these from those data tables. And so the transition from a data table to a search engine like this is not direct. And so we had to make some modifications. But for mitigation received dose, it says radiation dose burden for response personnel is a concern and must be reduced. And so it includes methods that can reduce this. Included here as well, which is not shown. Well, for instance, let's click on mitigation of received dose to first responders, and then we'll be able to see the scenarios that are contained within that. So these are more specific objectives from the broad support goal of mitigation of received dose. And so move contaminated debris. If you read that expanded explanation of it, it essentially says there'll be contaminated material. We may need to remove the debris which will be contaminated. How would you do such things? In the next one, spray water. We're concerned with airborne hazards. And so how do we, what types of techniques can we use to reduce that airborne hazard? And so we have spraying water, granulated cover is another one. We can spread that over the top of the contaminated material, or we can spread polymers and such. One thing that is not shown here yet, but will be included in the newer version, is critical infrastructure. So there'll be a specific response scenario that will be focused on different types of critical infrastructure. For instance, wastewater plants. How can wastewater plants prepare for incoming contaminated water and mitigate the effects of that water? And so that we feel that that's going to be an important addition to the next generation of this tool, which should be out in about several weeks to a month. You'll notice here symbols. So the dartboard or the bullseye with the dart in the middle, those are support goals. The scenarios are shown by what looks like a piece of film from a movie clip. And recovery methods, these are actual methods. So if we click on that, the recovery method has this symbol of somebody working. It looks like they're trying to shovel something. So they're doing or performing a method. And so if you click on recovery methods, the tool will simply just show you the list of all of the methods that are contained and described. And many of these types of methods, for those that have to do with decontamination, are going to be directly correlated to the methods that, for instance, show up in the Army field manuals and in the UK handbook for recovery. If you click on the equipment types, it'll give you the long list of all of the different types of equipment that are contained in the tool. I'm not going to go all the way to the bottom, but many of these are municipal equipment or public works equipment. And so we have correlations with public works databases, federal databases. So let's go back to the support goals. And now let's pretend that we have, for instance, we're planning, doing a tabletop exercise. And we're worried about, initially after the incident, we're worried about wastewater. This could be from firefighting activities. It could be from early on decontamination activities where we want to knock down doses where it's possible and feasible. But we have an understanding from the water reclamation districts and the wastewater plants that they're not prepared to handle wastewater incoming into the sewer system for those cities that have sewer systems to divert the water completely to these facilities. But we have an understanding from these wastewater facilities that they are not prepared to handle this water, either because they don't have the equipment to perform to measure the radiation levels so that they can guarantee protection of their workers. But they're also just, there's very little information on the deposition of the radioactivity from the water throughout the plant. Does the radioactivity concentrate in one unit operation as opposed to another? Does it clear its way through the plant and so the plant is not affected? There's very little information on that. So the wastewater plants would say that please do not send this water to our facilities. So let's click on wastewater and other waste generated. So we add this into the active plan. And when we do that, we'll see that the other 4 support goals disappear from the active plan, and now the wizard understands that we are concentrating on wastewater. And immediately the wizard starts to ask questions because it's trying to refine its search in order to help the user. For now, we're going to ignore these, but right off the bat, it's asking, is it a building exterior or is it an outdoor area? And from that information, it can better suggest items. So we'll look at that a little bit later if there's time. So we've talked about that in this hypothetical scenario, our objective is to avoid the sewer system. So here it understands that avoiding the sewer system is one of the options within containment of wastewater. So this is a scenario within the support goal of wastewater. And so that lines up correctly with what our hypothetical situation. So we're going to add that to the active plan. So when we add that to the active plan, it shows up as avoiding sewers. And now the wizard will understand, okay, you've chosen a support goal and now you've chosen a scenario. It can start making inferences on the methods that you're looking to include in your plan. And so what the wizard will do, it will start to mark its more suggested items over its less suggested items. So I hope you can see this here. This is a light bulb that's showing up nice and bright. And that's because the wizard thinks, oh, okay, they're trying to get to the recovery method of diverting water to avoid the sewers. But the wizard also says, well, maybe that's the primary objective, but maybe the stakeholder doesn't understand or has not thought yet that there's other ways. You can filter the water. So if you filter the water to remove particulate solids, they contain the majority of radioactivity. So it may be sufficient to filter the water, and you might want to consider that in one of your exercises, or explore filter water further to understand the totality of the method and how it would be used. But for this demonstration, we're going to go with the divert water that has been suggested strongly by the tool. And so we're going to add that into the active plan. Now the wizard understands that we have a support goal, a scenario, and a recovery method, and it could start thinking about tactics. And so these tactics show up as tools. So these are equipment types. And again, the wizard is going to, based on your input, of which we have not input a whole lot, but based on your input, it's going to start recommending highly and less highly other types of equipment types. So a gutter drain, okay, well, a gutter drain, what is that? Capturing water from gutters allows for washdown of roofs, okay? So the tool is suggesting that perhaps gutter drains would be helpful as you're trying to divert water and ensure that they don't enter the sewer system. Well, maybe I want a little bit more information on gutter drains so I really understand what they mean. Okay, and so it tells you, again, that brief explanation. A lot of these will be expanded in the newer version of the tool. And then it starts to give some of the attributes for the gutter drains. One thing that's not shown, for instance, in gutter drains, in some of these it is shown, but in gutter drains it hasn't been included yet. All of these recovery methods and the equipment types will have an alias here showing first. So these aliases are other names for gutter drains because depending on the part of the country you're in, and certainly if our international partners are interested in this tool, these types of equipment are called different things depending on where you're at. So we try to capture all the different aliases for the terms of gutter drains. So downspouts is another one that would be more common in certain areas. So it gives advantages, limitations. It puts the target substance for that equipment type, and then gives information on cost rating, how the tool performs. In this case, this is an artifact of a prior version of the tool. So instead of how well does it do in terms of controlling the depth of water, the better term here in the newer tool will be its ability to divert water. How well does it divert water? In this case, it performs best at that because that's what gutter drains are designed to do, is to divert water off of a roof and put it into a known centralized locations. The skill rating for the tool, the size of application for the tool, and then it lists the recovery methods to which the tool is linked. Okay, and so it also will provide an image. So for some of these tools, they're not very well known, and so we provide an image for every single tool so that the user has a better understanding of what that tool looks like or what that equipment type looks like. And so here, this one just shows the downspout and the water exiting the downspout. Okay, so let's go back to our options. And so for this purpose, we're going to say, okay, we want to consider gutter drain, so we'll add that into the tool. Sandbags is a very well-known method, so let's add that to the tool. Spill barriers, again, spill barriers, we don't have the image there yet, but it gives some information on what the spill barriers are, and so we will have pictures to show that there's many different types of spill barriers. And so let's add that to the tool. And for this purpose, let's say, okay, we've got the information that we're interested in. So now at this point, all of the information is here in the active plan. We can print this out as an equipment list. And so it simply regenerates the attribute information for these different equipment types and then lists them here. Other things that will be included that are not showing up yet, because this is an older version again, will be guidance on the use of that type of equipment, any prior information or knowledge about of its use for this particular function of diverting contaminated water, information on the availability, because that could be a major factor on whether you determine that that tool would be useful in your particular situation or not. Is it available, or is it a unique type of equipment that may not be immediately available? And so if you're interested in something in the early phase, that type of tool may not be something you would want to pick because it's going to take a long time in order to procure that tool. Cost information, where it's available for public works type of equipment, will be shown here as well. So there will be a link to the federal public works reimbursement list. So it'll show it'll show a quantitative cost rather than the simple qualitative cost rating that we provide in the tool. So at this point, we have our information in the tool, are in the active plan. We may want to just explore, for instance, some of the artificial intelligence information here. And so an observation from the artificial intelligence is that, are you insinuating that you have a building exterior? Well, let's say that, yeah, maybe we're interested in washing down buildings and diverting that water. So let's add that into the tool. And once you do that, it starts, not only will it start to, it will look at the equipment types that you have not selected and start suggesting some of them. But it will also start to ask other questions. Are there humans in the area? Are there animals in the area? Are there a lot of vehicles, residential units? And it's from this type of knowledge that the tool can start making assessments. For instance, if there's a lot of residential units, then you may need a piece of equipment that can be used for many different types of units and not something that is specifically designed for one single location. So you might want to, the tool will recommend, or the wizard will recommend tools that may be more useful for multiple units rather than to one large area, for instance. Okay, I think at this point, I'd like to stop demonstrating the tool and get back to the slides and see if there's any questions that we can answer. And Char, if you can show the next slide, please. So in summary, the RRLT output will be recommended methods and tools to accomplish a goal with information provided to help the stakeholders understand how to use the tool, its availability, its cost, and information on best practices to date. The potential uses that we envision are either tabletop exercises, identification of equipment needs prior to an incident, perhaps stockpiling, which we would prefer not to do, but that may more importantly identifying with our partners and through our agreements what tools are available regionally or nationally that can be brought in to areas to make sure that a gap is filled. And the third is by planning sections for the incident command structure following an incident to help them plan their response and recovery operations. Our current effort focuses on populating the guidance and best practice information along with availability and linking to the new federal reimbursement cost database. We're still working on the AI wizard algorithms, and that's where we're looking for a lot of stakeholder feedback, is how they think the tool could better be structured to help them make decisions and understand their options. And then simplifying the navigation experience. I mentioned a few times that the next version of the RRLT has different format and nomenclature, and that's this effort to try to simplify the navigation experience. The other thing that it's quite important, I think, is that a similar type of tool could be developed for biological and chemical incidents, because in many aspects the recovery methods are very similar. The broad methods of dealing with contaminated water and contaminated surfaces, they're similar between biological and chemical incidents. And so it's easy to see how a similar type of tool can be developed for that. Next slide, please. And so Matthew and I would like to thank you for your participation, and we'd like to ask for your feedback. It's very important for us, and that's one of the reasons why we're trying to advertise this tool in as many different venues as possible, is to try to get your feedback, because we are still in the middle of developing this tool. So if we can develop it to better hit the objectives of the stakeholders around the country, then we are amenable to those types of suggestions and would like to make this tool as easily operational as possible. So we asked the questions: how would your organization utilize the equipment selection tool, and do you have recommendations on how that the navigation and obtaining the active plan can be more streamlined or simplified, or added, or information added to better reach your goals? And are there other parts of your organization that we should reach out to demonstrate the tool and ask for feedback on its operation? Is there a next slide? Or?
I think that's it. Hey, Michael. So there's a couple questions. The first one I think is for Matthew, and Matthew, I know you answered already a similar question to this, and I published it without the answer, so I apologize. But how are the contamination maps generated? By measure radiation, or by mathematical statistical models, or a combination?
Sure. So the maps were the ones on an earlier slide, and there were three maps. One for the plume model from a nuclear device detonation in New York City, one for a radiological dispersion device in Philadelphia, and the third one was for Fukushima. Yes, we're getting back there. So the plume models on the left were generated by atmospheric plume models that have been developed over several years for various types of releases, including radiological releases, and they're often run by the National Atmospheric Release Advisory Center, which also does atmospheric modeling in support of various sorts of weather events and other sorts of plumes other than radiological plumes. So those are all calculated based on number of inputs, including wind direction and topography and other factors. The Fukushima one also includes, since it's a diagram of the area that is decontaminated, that did include measurements, you know, so that the government did not end up decontaminating places that did not need decontaminated. So I hope that answers your question, and thanks for the question.
Thanks, Matthew. So another question is, if discussing an IND, and I don't know what that means, but I'm sure you guys do, or large-scale nuclear event, what implications will the EMP from the detonation have on infrastructure and technology? Will our computer-based technology still be viable?
Matthew, do you want to handle that?
So this particular tool does not include the continuing viability of electronics after an electromagnetic pulse from a nuclear detonation. I believe there's other parts of the government that are interested in survivability of infrastructure and electronics from that sort of event. Mike, was there something that you would like to add to that?
No, I think that captures it, Matthew.
All right, next question is, how robust is the system in the face of a real event when multiple users from various levels, local, state, tribal, federal, are all trying to use it at the same time?
I think I can handle that one. So right now we are, since we're still in the development phase of the tool, we are considering quite a few different options on how this tool would be deployed and on what platforms and backup platforms would be available. Argonne National Laboratory has quite a bit of experience with these types of tools. Web-based or software-based tools that are used to organize efforts and understand the movement of equipment. And so our team is pretty well versed on how to establish redundancies and enough bandwidth to allow the users to operate the tool even with a large number of users.
Great. The next question is EPA going to advance the further development of the RRLT using artificial intelligence and Bayesian statistical models?
So,
Mike,
yeah, so our AI team at Argonne is using their methods, and I will admit right now I am not an expert in AI, and in fact to even suggest that I'm not an expert in AI is an insult to anybody who understands AI. We have a team that's well versed on AI, and so I'm not exactly sure of the types of methods, but I can get back to you with that when we consult our AI developer on the team.
Does the tool address ultimate decontamination or disposition of the equipment that is ultimately used?
I'm not sure I understand that tool address ultimate decontamination or disposition of the equipment. That is, so the tool will understand, it will understand the types of decontamination that you want to perform. It will not ask you whether you want to decontaminate to free release, because that's not understood yet. Meaning you have a contamination target level that you're willing to accept, and then you'll call the job done, and then people can reoccupy. That has not been established, and so the tool will not recognize that. But the tool will recognize whether you need methods that can be deployed quickly, whether you need methods that can be deployed with those who are of limited skill. It will understand whether you have equipment that requires special skill and you have those special skilled people involved. It will understand that through the questions that it asks. And so we didn't get a chance to see the number of questions that are available, but it will understand those types of aspects of any of the recovery methods.
Does the tool adapt to locations outside of large urban centers, for example, suburban or rural areas, for example, from a transport incident like a train derailment?
Yeah, so that's a really interesting question. So we spent quite a bit of time, for instance, discussing any type of contamination that would involve railroads. And we talked to one of the biggest railroad companies in the country to discuss their options and their tactics that they have available and use for other types of hazardous chemical incidents. And so the tool will not directly ask you whether this contamination is on a rail line, but in the critical infrastructure section of the tool, it will provide guidance on if the railroads are involved, what type of methods they have available to them.
Thanks, Michael. Have you considered studying where radioactivity may concentrate in wastewater treatment plants? In some cities, the stormwater and sanitary sewer water mix so that if it rains during or post-incident, the radioactivity could theoretically make it into the wastewater treatment plant. Do we resort to measurements to find it at the wastewater treatment plant, or is it worth the effort to determine now where rad material may accumulate? Would that be another model for the logistics app?
Yeah, so that's another very, very good question. So we've spent quite a few years, Matthew and I, proposing to different organizations that we need to study the disposition of radioactivity in these wastewater plants, because our best knowledge of it comes from what I would call secondary studies after Fukushima, where there was very small amounts of radioactivity found in the plant. And the results that came out of those studies showed that they were quite surprised that the radioactivity was distributing everywhere in the plant. So one of the problems that was suggested by that question was that we don't have the ability to measure the radioactivity. When I was talking to the largest wastewater reclamation district in the entire United States, they said they don't have the equipment. They just don't have the equipment or the training to go into the unit operations and understand how much radioactivity has been deposited. So first, we don't know where in the plant exactly the radioactivity is going to be deposited. Rainwater will certainly be an issue, and one of the recovery methods, one of the equipment types that's listed in the tool is actually rainwater, because we anticipate that rainwater, that in most parts of the country every 3 days it rains, so you have to anticipate that there will be a rain event, and so that water will be going to the reclamation district, diluting that radioactivity down, and so we've considered how you would deal with that, and I think we've got solutions that work with very little additional equipment requirements and using the same type of expertise that already exists at these reclamation districts. But I would certainly advocate for a study that looks specifically at understanding the mechanisms for the deposition of radioactivity in different parts of a water treatment plant. I think it's very, very important. Not only wastewater, but drinking water as well, because we have a standing policy on how to handle drinking water under contamination events, and that policy is not robust enough against the different types of scenarios that we envision.
Thanks, Michael. And at the state level, who would have access to the tool?
So that is something that we are discussing with all of the developers of the tool, EPA, DHS, FEMA, and Argonne. Right now, in order to log into the tool, you would need a web EOC credential. If you are not if you do not have an Argonne National Laboratory credential. But we've talked about opening it up, so it's like many other tools. For instance, Rad Responder, which is opened up to state and local upon request to the developer, and that to the organization that holds that tool, which is FEMA. So we are considering all types of options for access into the tool. One of the things that I have been advocating from before we started the tool was making this information also available to our international partners. In fact, our international partners were very instrumental in launching the studies that led to this tool. We had partners from our international partners were very involved in the brainstorming activities and providing guidance on their environmental restoration activities that helped us to develop a lot of these methods and recommendations.
Thank you. And I think we've got time for at least one last question, but does the tool include radiological monitoring equipment, for example, air samplers or instrumentation?
Yeah, so I didn't get to that in the tool. If it's okay, can I share my screen real quickly, and I can just give an overview, a listing?
Sure, go ahead.
Okay. So if we look here at the response or at the support goals and we click on survey and monitoring, what we'll see is that there'll be activities associated with critical infrastructure, dose at the street, measuring dose indoors, monitoring the movement of traffic and the movement of contamination because of the movement of traffic, resuspended material that occurs at the street level. So methods of dealing with suspension at the street level. This would be important for movement of people or vehicles during an evacuation, for instance, or even during the recovery phase. And then tracking contamination routes. Say we are evacuating an area. We want to track those contamination routes, which would be the major thoroughfares leaving the city, the bridges, for instance, as well. How would we do these things? And so the tool will the tool will include these different types of recovery methods, say for air contamination monitoring. It includes a number of those equipment types. So these could be base stations, building air filters. A lot of these, remember, this is not only, we're not trying to just tap into established techniques that, for instance, have qualifications and certifications associated with them, like your conventional air filters that you would have, for instance, at a nuclear power station. We're trying to think outside the box because we understand that we won't have the capability to use all of those specialty types of equipment in such a wide area. So certain things like building air filters, we know from incidents that happened recently, for instance, that radioactive releases you will find the radioactivity concentrated in building air filters. Well, maybe we can use that to our advantage. In the same way, vehicle air filters. A study by Lawrence Livermore National Laboratory showed that scanning vehicle air filters is a potential way of monitoring the movement of contamination because of the movement of vehicles. Are there any other questions?
We do have more questions, but we are at 3 o'clock now, so I think we will wrap things up.
Do we have a hard stop, or can we answer more questions for those who want to stay online? I know that there are people from I know some of the EPA folks are hosting it. I do not have the luxury of extending their schedule, so.
Well, I can say for myself as a producer, if you'd like to take more questions, you know, I have time to continue.
Yeah, I would not. I would enjoy to answer more of the questions to have our viewers understand some of these answers before they leave.
Okay. Well, let's see what else we have here. So here's a question. Will the tool also include the integration of adequate potable water supplies to responders, also prevention of cross-contamination of utilities, water mains in the area?
So the tool will not understand if there are potable water supplies available. It will notify the user that potable water is necessary in order to use the tool. So that's a really interesting question, because one of the things that could be integrated into the artificial intelligence is to add questions that prompt the user to answer what are the possible constraints that they have in this particular situation. One of the line items of data that shows up for each one of these equipment types is the requirements for their use. So electricity requirements, manpower requirements, and resource requirements such as fuel, water, etc.
Okay, great. I am going to see another one. Does the software take into account half-life of isotopes? If contamination is short-lived, like hours or days, release of contaminated water might not be a long-term issue.
Yes, right now the tool does not recognize the type of radioisotopes. So we already have a tool called the DCON tool, the RAD DCON tool, which sits on RAD Responder, and the RAD DCON tool asks those exact type of questions. So we avoided including any of that information in the model because it's already done in another tool. So and it's also a FEMA tool. So we're hoping that the stakeholders will understand that there is a number of tools that can be used, and they have their specialties. And the RAD DCON tool specialty is to understand the implications of different types of radioactive contamination. Oh, and I want to correct myself. I think I said that it was Lawrence Livermore National Laboratory that produced that study on air filters for cars. I don't remember if it's Lawrence Livermore or if it was Pacific Northwest National Laboratory or Oak Ridge, or it's one of the sister laboratories to Argonne, but I don't remember exactly which laboratory it was that published that study, so I apologize if I misspoke.
Okay. So the Navy has monitoring equipment around various cities that support their operations. Have you tapped into these sources of information?
Yeah, so we've discussed with a number of the stakeholders their equipment capabilities in the different cities. So we have a basic understanding of what those equipment capabilities are. But again, those types of tools that are very specific to those organizations, we are hoping that that information will be brought into these planning processes as other options for instance, monitoring. We couldn't possibly capture every single type of device that's out there and who may own that device. That would require not only a tremendous amount of effort to obtain that data, but it would have to be constantly updated, which is not something we want to have for the tool. And so we leave those descriptions quite generic. You're not going to see in our tool a specific model or a specific make of a device. Instead, we use broad terms to discuss what that device does. And then it's up to the planning sections or the stakeholders to identify what are the specific makes and models that they have available to them.
Okay, great. So it looks like I've got one more question in here, so this will be our last one. Is it planned to store information or the AI to integrate results and data on historical and active contaminated sites when using the tools for a current active plan or response?
Okay, as well as we can, we're trying to integrate the data that's available today on the use of these types of tools and methods in the field, and then the lessons learned. So not only efficacy information, because that's where our efficacy numbers are going to be coming from. And so I should have mentioned when I was demonstrating the tool that another factor will be how well this tool performs, and we have a qualitative evaluation of that. There'll be quantitative data showing there in the guidance on how well this tool performed. That data already exists in these data sheets. They just have not been integrated into the AI model. It will not be able to update based on incoming information or new information unless we are specifically, and we meaning the developers, are specifically tasked with revising the model to include those types of updates.
Thank you, Michael, for the questions, answering the questions, and to you, Matthew, for presenting. That concludes our webinar. Thank you all for attending. Have a great afternoon.